In this video, let's go over the squeeze theorem. Sometimes it's also called either the Vice theorem or the pinching theorem or sandwich theorem, but most commonly people call it the squeeze theorem. It says that if f of x is less than or equal to g of x, and g of x is less than or equal to h of x, then for all a not equal to x, and the limit as x approaches a of g of x equals the limit as x approaches a of h of x equals L, then the limit as x approaches a of g of x also equals L. And that sounds pretty complicated, but we can make it much simpler if we just draw a picture. So say we have this graph right here. And we'll have this g of x line. Let's say it's doing this right here. Well, we know that so this is our f of x line. I think I might have just now called that g of x. That's supposed to be our f of x line. Then g of x, at any point, it is either equal to this line or it's above it. So let's go with a line, and we'll put it right there. So notice at this point they're equal, but everywhere else it's above it. So that'll be our g of x line. And then let's go for our h of x line. So the h of x line has to be either above the g of x line or equal to it. So let's say it also meets at that point right there. And we'll call that point, let's see, we'll call it x equals a. So this is the point that they're all approaching. The squeeze theorem says that because the orange line, h of x, equals f of x, that this g line in the middle must also equal that, because it has to be above the green but below the orange, so this pink line must be equal to them. So let's go over a actual example with the squeeze theorem, something a little more substantive. So we'll say example. Say find the limit of, well, say limit as x approaches 0 of x times the cosine of 1 over x. And this is an example I thought of ahead of time, and actually have a graph of it that I'm going to pull up here after we're done. Well, we know from trigonometry that cosine of x must be between -1 and 1. So we'll just say recall cosine. Actually, let me write that out here. So recall that cosine of x is either less than or equal to 1, but it is greater than or equal to -1. That's a very important fact for that. And that's true for all x. Well, then we know that, one more thing. So then we know that -x, so, well, the negative absolute value of x is less than or equal to x times the cosine of 1 over x, which is less than or equal to regular x. That's just an extension of this. This was our simple example. This follows from that. And that's for all x not equal to 0. So anytime x is bigger than 0 or smaller than 0, this holds true. So we know that. So the closer x gets to 0, the closer x times the cosine of 1 over x gets to 0. Then the limit as x approaches 0 of x times the cosine of 1 over x equals 0. Because as it's getting close to 0 from both sides, x is being squeezed into 0 there. So that's why it's known as the squeeze theorem. And let's show the graph of that. The graph of that looks similar to this. Now, see here at the center of the graph, where it starts going up a little, then down, then up again. There should actually be an infinite number of lines here, and it should get very thick through here, because there's that infinite number of up and down lines as it gets closer and closer. Now, it'll follow the same general pattern until it gets to x's less than, until it gets to the values of 1 and -1, in which case it goes off to infinity. But this should be a little bit thicker, should look kind of like well, it's very thick in the middle because there's an infinite number of lines. This was just a problem with the graphing software I used. I couldn't find a better picture of it. But that's the squeeze theorem, and it's something that's pretty intuitive. It's something that I think most people already understood. I just didn't know mathematically what the squeeze theorem was, saying that, hey, if this orange line actually equals this green line, and this pink one must have been in between them or equal to them, it must also equal these other lines.